Hello everyone, welcome. Um, Today's lesson is going to be a recorded form. Yeah, so this session is basically both um, live and recorded forms. So please bear with us, and then let's continue from where we left off the other time. So basically, we've been talking about algebraic expressions, and we've looked at different things under this topic. We've looked at addition of algebraic expressions. We looked at multiplication of algebraic expressions. We look at divisions, subtractions, and all that. Then fast forward, we went to factorization. Under factorization, we talked about the types of factorizations we have. So basically, under factorization, we talked about under factorization, we basically talked about the different types of factorization. So we have the common method, then we have the grouping method, and then we have the quadratic trinomials. So we talked about these three methods that we use. Then after that, we said there is also difference of two squares, right? Of two squares, which we've also talked about it and given ourselves some examples. So today we are going to continue with more examples of the difference of two squares. Then we will delve into operations in algebraic fractions. Alright, so before we continue, just take 10 minutes to answer this difference of two square questions. Just 10 minutes of your time to answer this difference of two squares, or to answer these questions. So this will be, I don't know, I think exercise 7 or so, yeah. So yeah, okay, so I think exercise 7. So try the following. So this basically is a combination of all what we've done so far before we move on to the next tense. So question 1. So you have to factorize completely. So we have e to be 3x squared. Okay. 49x squared minus 9y squared. Let's see. So C 24x to the power 4 plus 18x to the power 3 plus 3x squared. Okay. Then what again? Okay. D 4 x squared minus 8x plus 3. What again? Okay. Then question 2. Find Q if 3Q plus 13 squared is equal to 16 squared. So basically, you're using like 10 minutes. Okay, probably 20 minutes. So use 20 minutes too. So let's say if you use 5 minutes to solve one question. 1, 2, 3, 5, 10, 15, 20. Okay, 5 minutes is too much. So let's use 4 minutes to solve one question. Okay, so 4, 5, 20. They are basically 5 questions. So just use 4 minutes to solve 4 minutes to solve it. Yeah. So in the next 20 minutes, you put your answer down. Then we'll solve it together too, as well, to see what we are going to get. Please let your answers be in the comment section. Once you are done, type your answers in the comment section. Yeah. Alright. Alright, so 20 minutes is over. Let's solve the question. So question 1, 3x squared plus 2xy minus 12xz minus 8yz. So what do we do? Grouping method, right? So for this particular one, the common variable here is x. So x will definitely go outside the bracket. Then we have 3x inside the bracket plus 2y minus, so between 8 and 12, what is the highest common factor? 4, right? Because 4 will go into 12, 3, 4 will go into 8 too. So 4. So 4 will come out, and the variables, between the variables, which one is the common factor? The common factor among the variable is what? Is z. So 4z, and what is going to be left? 3x plus 2y. So what are we going to get in the end? X minus 4z, 3x plus 2y. So that is for question 1. And for question 2, what do we have? We have a difference of two square situation, the b. We have 49 s squared minus 9y squared. So what are we going to ask ourselves? We are going to ask ourselves, what is the root of 49 and then 9, and we are going to square those roots. So what is the root of 49? 7. So 7 squared s squared minus 3 squared, and I said this can be rewritten as what? 7x all squared minus 3y all squared. And if you are to get to this situation, you've gotten a difference of two square situation. So it's going to be 7x minus 3y, 7x plus 3y. And that becomes the answer. Then let's look at question C. So for the C, we have 24x to the power 4 plus 18x exponent 3 plus 3x squared. And then we have to factorize this. So first of all, we are going to use grouping method first to sort out the x, to reduce it a little bit. So you could see that this one, the factor is definitely going to be 3x squared. So 3x squared is going to be the factor. And then what is going to be left? You divide 3x squared by 24. What are you going to get? 3 times 8 is 24. So we have 8x squared plus 6, right? So 6x plus 1. So now you've seen that we've gotten a quadratic trinomial. So we have 3x squared outside the bracket, then our quadratic trinomial. And what did I say about the quadratic trinomial? If you have a calculator, you can solve it easily. But if you don't have a calculator, you multiply a by c, right? And then you are going to get 8. So 8 times 1 is going to give you 8. So if you're looking for two numbers that when you multiply, you get 8, but when you add, you get 6. So definitely 2 and then 4, right? And 2 plus 4 will give you what? 6. And then 2 times 4 will give you what? 8. So 2 and 4. So 8x squared plus 2x plus 4x plus 1. And what are you going to get? You are going to get 3x. Oops. Okay. You are going to get 3x squared into bracket. This one, you are definitely going to group them. So what is the common factor here? The common factor here is definitely 2x. Here you get 4x plus 1. And what is the common factor here? 1. 4x plus 1, because when you multiply 1 through, you have to get the same thing. So now the final answer becomes 3x squared, 2x plus 1, 4x plus 1, and that becomes our final answer. I believe you are taking notice of what is going on. In this particular one, we use the grouping method first to factor 3x squared out. Then what was left in the bracket? 8x squared plus 6x plus 1. Because when you multiply 3x squared through by this, you are going to get this. So you realize that the one in the bracket is a quadratic trinomial. Then you use the quadratic trinomial method to what? To simplify and get your final answer. So basically that is it. Then let's go to question D. So question D, what does it say? So we have okay, question D. So the D, what do we have? 4x squared minus 8x plus 3. So this is definitely a quadratic trinomial case. So what are you going to do in this case? You are going to multiply this by this to get what? 4 times 3 is going to give us 12. So we are looking for two numbers that when we multiply we will get 12, but when we add we will get negative 8. So what are the factors of 12? So to me, negative 6 times negative 2 will give you positive 12, and negative 6 plus negative 2 will give you negative 8. So definitely the answer is negative 6 and negative 2. So you are going to replace negative 8x with negative 6 and negative 2. So 4x squared minus 6x minus 2x plus 3. You group them. So what is the common factor over here? In this case, the common factor here will be 2, right? So 2x comes outside the bracket, then what do we have here? 2x minus, what do we have here? 3 minus, so here we have to get 2x minus 3. The reason why it's minus 3 is because, so there is 1 here. When you multiply the 1 by the negative 3, you are going to get positive. So you now have 2x plus 1, 2x minus 3, and this becomes your final answer. When you expand this, you are supposed to get 4x squared minus 8x plus 3. Then the last question 2. So we have to find Q. We have to find Q. If 3Q plus 13 squared is equal to 16 squared. So this is basically a very simple thing that you can do, right? So in order for you to find your what do we call it, your Q, you are definitely going to send this one to the other side. So your 3Q will be equal to 16 squared minus 13 squared. Okay, so in this case, what are you going to do? So you can simplify 16 squared. You can straightforward simplify 16 squared, which will give you 256 minus 13 squared, which will give you 169. 3Q. So 256 minus 169 will give you 87. Divide here by 3, divide here by 3. 87 divided by 3 will give you 29. And that becomes your value of Q. You can also use difference of two squares to solve this particular one. Let's see how we can leverage on difference of two squares to solve this particular one. So we have a first method and a second method. So we have 3Q plus 13 square minus 16 square. 13 squared equal to 16 squared. So if you want to find 3Q, you are definitely going to make 3Q the subject. 16 squared minus 13 squared. And what are we going to get? We have a difference of two square situation here. So 3Q will be equal to 16 plus 13. 16 minus 13. 3Q equal to 16 plus 13 is what? We have 29 multiplying 16 minus 13 is what? 3. We divide here by 3, we divide here by 3. Q is equal to 3 cancel 3. 29. So basically that is it. Now let's move on to operations. I think we've done enough of everything. Let's move on to operations in algebraic fractions. And for algebraic fractions, when we were doing division of algebraic expression, we talked a lot about algebraic fractions. So let's look at algebraic fractions. So basically it's operations in algebraic fractions. Now, in algebraic fractions, if we have, for instance, a over b times x over y, we know it's definitely ax over by. So that is basically what is it. So for example, if we have 5x squared over 3xy times 9y squared over 20, you know how definitely this is going to be. This is just like normal fractions. 3 go into itself 1, 3 go into 9, how many times? 3. 5 go into itself 1, 5 go into 20, how many times? 4. So now what do we get? We get 3 s squared y squared all over 4xy. And at this point, what do you think we will do? We will take our 3/4, and then we will deal with this one. So here, what do we get? We get xy still. So now we can see we have 3xy all on 4. So this is basically, we've done this one, yes, in division of algebraic expressions. It's literally the same thing. Now let's delve into more complex ones and see how we can solve them. Okay. So let's see. So we have simplify. We have to simplify this. 12xy over 7 multiplying 14x over 20. 7 will go into itself 1. 7 will go into 14 how many times? 2. 6. 5 2 will go into here how many times? 6. 2 will go in how many times? 10 20s. Okay, so 2 will go in how many times? 3 go here 5. You can also use 4 to cancel. You will still get a 3/5. Then what do you have here? So when you multiply the variables, you're going to get 6x squared y all divided by 5. And this becomes your final answer. Let's try another example. So in another example, we have 3ab on 15c squared d cubed times 10 d to the power 4 over 9e to the power 2. So this one too is very simple. You can solve it strategically. You can just write 3ab dot, which will represent your times, right? 10d to the power 4 all on 15c squared d dot 9 to the power a squared. So definitely 5 will go into 15 3 times, 5 will go into 10 2 times, 3 will go into itself 1, 2 go into 9 3 times. So what do we have now? Let's break it down. Now we have ab multiplying 2d exponent 4 all on 3c squared d multiplying 3a squared. So basically this is what we have. Okay, so here is d cubed, so d cubed. So now, how do we break this one down more further? So this e will cancel all of this e, and for this particular one, we are going to get what? This is d to the exponent 3, and this is d exponent 4. So definitely the d will cancel, and to be left only just d. It will only be left with d, because it will be 4 minus 3, which is 1. So it's going to be left with d. So now what do we have again? We have 2b d all on 3. So 3 by 3 will give us 9. So 9, remember 3 times 3 here, all on 9 a c squared. And this becomes our final answer. So when you get something like this, just relax and then break them down nicely. Let's see if we can try another one. So let's try another one and see something. So let's try. Let me take this one. So we also have another situation: 6x squared plus 2x y all on 5z times 15z squared all on 3x plus y. So this particular one too is nothing difficult. It shouldn't challenge you. It's a very simple question. You just have to be very strategic. So cross multiplication, as far as cross multiplication is concerned, 5 going to itself 1, 5 going to 3, 15 how many times 3? Z will cancel 1, and then to cancel one of this, so it will only be left with Z here. So it means we are done with the Z aspect. So we cannot just multiply this one, cancel this one by this throughout. No. So 6x squared plus 2xy times 3z all on 3x plus y. This is basically it. What do we have here? We are going to do some form of factorization, I guess. So we can factor for this particular one, we can do some factorizations over here and see what we will get. So we can factor 2 out for the numerator. So for this one, when we factor it, it will be 2x. Then what are we going to get here? We are going to get 3x plus y. Do you get the point? So now we have plus 3z all on 3x plus y. Since they are multiplying, this one can cancel this. Then what do we have here? We have 2x multiplying 3z. And what do we have as our final answer? 6xz. Let me take it again. In a situation like this, you do your cancellation first. After doing your cancellation, you get 6x squared plus 3x times 3z all on 3x plus y. Then you factorize using the common method, the numerator. When you factorize the numerator, realize that the one in the brackets and the denominator is the same, so they can cancel out. Once they cancel out, these 2x will multiply the 3z to get your 6xz. Okay, so if you have any question, you can note it down. The next time we meet, we look at whatever question that you are having, especially with regards to this particular lecture, so that we delve much deeper into it. So there are lots of examples we can try. So let's list some examples. Some of them may seem so complex, but don't worry, I've got you. So let's move on and see if we can try some more examples. Okay. So we are coming to solve plenty. So the question for us is to simplify the following. So simplify the following algebraic expression. So simplify the following algebraic expression. So the first one, we have 3x squared over 4y squared by 2y cubed over 9x. The second one, we have x squared plus 5x plus 6 over x squared minus 9 times x squared minus 8x plus 5 plus 15, all over x squared minus 4x minus 5. Then we have question 3. These questions, we have a on ax plus 2a squared by x squared minus 4a squared on x minus 2a. Then we have the fourth question, which is the fourth question, 6x squared y over 13p squared q times 39q squared r over 18 y squared z divided by x squared p squared over q x q r. So this one, since it's a little bit technical, I'm giving you 5 minutes each to finish solving. Once you are done solving, we will take a look at how it is solved. Then we bring the lesson to an end. So just 5 minutes, and 5 minutes for each question. So 20 minutes. Okay, so we are going to take a look at how each of these questions are solved. So let's see how we can solve these questions. There are 4 of them. Let's see how we can solve them. So the first one, I'm going to take my time to do the explanation well so that you get it. Okay, thickness, sure. So we have the first one to be 3x squared over 4y squared times 2y cubed over 9x squared 9x. So this is basically the simplest of all. So cross multiplication, 2 will go into itself 1, 2 will go into 4 how many times? 2, 3 will go into itself 1, 2 go into 9 how many times? 3. So now let's rewrite it. X squared y cubed all on 6 y xy squared. So at this point, this x will cancel this x to be left with only x here. This one, when we do the subtraction, we only get y. So we have xy to be our numerator, and then we just have 6 here. So this becomes our answer. Let's take a look at question 2. Question 2 is going to be quite plenty because of the nature of the question. So the question 2, we have different things all together. We have difference of 2 squares inside, we have quadratic trinomial inside, and then we have algebraic fractions as well. So for the question 2, we have x squared plus 5x plus 6. So this one, if you have your calculator, you can do the quadratic trinomial to get your factors somewhere. That's why I always encourage you to bring calculator. In ACHS Maths, the calculator helps us to speed up process. So you don't have to waste time solving the simple process you could have used calculator to get. So here our major burden is to convert these ones first. Convert these ones to their factorized forms. So if you do your quadratic trinomial and then you're able to do your factorization well, the first instance you get x plus 2, x plus 3 for the first one, divided by, we know this one is difference of 2 squares, right? So this one is definitely going to be what? X plus 3, x minus 3. This is a difference of 2 squares. By now you should know that this one will give you this. You should know. Difference of 2 squares. Then times this one too, we have x minus 5, x minus 3, all divided by x minus 5, x plus 1. So when you get a situation like this, cancellation becomes so easy. This cancels this. This cancels this. and then this cancels this. So what do we left here? What are we left with here? We are left with x plus 1 plus 2 over 1 multiplying 1 over x plus 1. And what is going to be the final answer? X plus 2 all on what? X plus 1. Basically, that is the answer. Okay, for question 2. So take notice of how I'm solving it. It's very, 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 very necessary. Very, 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 very important. So let's take a look at question number 3. So question 3 is somehow similar. So always when you see things like this, you do factorization first so that it will help you cancel out. So in this situation, what do we have? A on ax plus 2a squared times s squared minus 4a squared over x minus 2a. What then do we have over here? We should first factorize first, right? So in the course of the factorization, what do we have? We can get a over, for this one we factor a out, a x plus, okay, 2a times, okay, so for this particular one, what can we do about it? We have x squared minus 4a squared. So definitely difference of two squares. So here is going to be, we can rewrite it as, so you can do that one somewhere in your jotter. So you have s squared minus 4a squared is the same as s squared minus 2a all squared. And this becomes difference of two squares. And this will give you x plus 2a, x minus 2a. So this is basically, that's what you are going to get here. X plus 2a, x minus 2a, all on x minus 2a. So you see where we are driving at. This cancels this, and this cancels this. So what do we have here? A over a. And a over a is what? It's definitely 1. So our answer here is what? It's 1. That becomes the final answer. Alright. Now the last one, the Grand Master. Let's see how we are going. So for the last one, it's plenty do, but we will try our best to see how we can finish it up. So we have to be very, very, very patient and careful, because the fourth one is plenty. It's plenty. So let's rewrite it. We have 6x squared y on 13p squared q multiplying 39 q squared r on 18 y squared z divided by x squared p squared on xqr. So first of all, you have to do your division, make your division reciprocate your division. So here we can rewrite this as 6x squared y on 13p squared q times 39 q squared r over 18 y squared z. I've intentionally taken my time to speak very slow so that you can understand. Divided, so here reciprocation, so times the denominator will now be our numerator, xr over x squared p squared. Now what is left here is cancellation. Cancellation is what is left here. So here you are going to cancel 39 with 13, right? You know 13 times 3 will give you 39. So 13 going to itself 1. So going to 39 how many times? 3 times. So we've dealt with the values between 13 and 39. We've dealt with that. Then for here 6 going to itself 1, it's going to 18. 3. Good. It means we've dealt with that one too. Now what are we left with? So we can come down here and then rephrase everything to make it look nice. So now we have x squared y. Even here 3 can go into itself 1. It can go into 3 1. So we now have x squared y over p squared q times q squared r over y squared z times x q r on x squared p squared. So now basically what is left? Cancellation. Cancellation is basically what is left. Okay, so let's just glance through very well and see how we can resolve this. So first of all, let's rewrite this. So when we are multiplying all the numerator, what are we going to get? X squared y q. So this one x squared times, so these are all multiplication. Dots, you can bring the dots just to denote multiplication so that you don't get confused. Q, because q squared times q squared times q will give you q cube r squared, all on, what do we have here? P squared q. Okay, so p raised to the power 4 because we have p, another p here, so that is one like term. Q, there is no like term for q, there is no like term for y, there is no like term for z. So q y squared, there's also no like term for x. X squared, so we have p for y squared, okay, and then z. So how many variables do we have for the denominator? 1 2 3 4 5. 1 2 3 4 5. Okay, since the p and p are like them, so we just count both of them as 1. So now let's see how we can resolve this particular one. S square will cancel S square. Okay, this y will cancel this y1, so y times. So let's rewrite what we now have here. We now have q cube r squared over p to the power 4 q again y z. So q, go here 1, go here q squared. So we now have q squared r on p to the power 4 y z. At this point we can't break it any further, so this becomes our answer. Now how did we arrive at this answer? So I said this particular one is strategic. You just have to be very, very careful in your dealings. First of all, you do your reciprocation, then you cancel out the values, and then you restructure. After restructuring, this is what you're going to get. When you get to this particular way too, you are going to multiply all the numerators and all the denominators. After multiplying the numerators, this was what we had: s squared y by q to the power 3 r squared. And when we multiply the denominators, we had p raised to the power 4 q y squared x squared z. Then we did our cancellation out. Then we came up with this and we further cancelled, and then we finally arrived at this. So basically this is what algebraic fractions is about. You see, it's some way, but you just have to relax, take your time. This one you have to be really good at your fractions. Your fractions has to work, and you have to know the rules when you have to reciprocate and all that. So basically this is it for the lesson, and I just hope you enjoy it. If you have any questions, you can let me know in the comment section. Yeah, or you can write it somewhere. When we meet tomorrow, God willing, we will discuss them. So basically that is it. So what have we done today? We did a quick revision on what we've done so far. So we've done factorization, common method, grouping method, quadratic trinomials. We've also tackled difference of two squares, and we gave ourselves effects examples to try, to refresh our minds. And here we were able to get a very nice work done here, as you can see from the board. And then here too the same thing. Then here too same. So after that we introduced ourselves to algebraic fractions, and we talked about some few rules. Then we started solving problems. So the first one was for us to simplify this. And as I said earlier on, algebraic fractions, what do? You cross multiply like just the normal fraction, so you can cross cancel. Let me say it that way. You cross cancel. So you see, in fractions, you know how you can cancel. You can cancel either vertically or diagonally. Vertically this way, diagonally this way. Okay. Alright. Then we looked at more further examples. Then yes, this particular question too, it was a very nice one. Then we came to solve this particular ones as well, plenty of them. So just take your time, look through well. This one is patience. It's required algebraic expressions. It requires patience. Relax. The things might seem so scattered and clumsy, but when you take your time and you solve it well, you see that you arrive at a very simplistic answer. Yeah, so basically that is it. If you have any questions, let me know. Alright. Do have a wonderful day. Bye bye.